Hi students, in this class I am explaining about the matter. Every object in the universe is made with the materials. That's why the scientists name them, those are matter. So, the air that we breathe and the food that we need and this duster and this whiteboard all are comes under matter. These matter exist in three forms. Those are solids, liquids and gases. These are called as the states of matter. Now I am explaining about the characteristics, means the properties of these solids, liquids and gases. First property is solids have fixed shape and fixed volume. That means if we consider this duster, this is a solid which have a fixed shape and also it occupies some space. That's why it has fixed volume. And next about the liquids. Liquids have no fixed shape but have fixed volume. For example, if we consider this water in a beaker, this water is not have a fixed shape but attain the shape of the container, and also it have a fixed volume, that is here it consists a 60 ml of water, like that it has a fixed volume. And gases have no fixed shape and no fixed volume. For example, the air that we breathe, which have not fixed shape and not fixed volume. Next, if we consider the diagrams, these represents how the particles are rearranged in the solids, liquids and gases. If you consider this diagram of solids, the particles are closely packed to each other. So here in liquids, the particles of liquids are loosely packed, whereas in gases, the particles are very loosely packed. By considering these diagrams of particles, we can tell the 2 points. Those are interparticle forces and about the interparticle distances. First, we come to the interparticle distances. Interparticle distance means it is the distance between the particle and the particle. The distance between the particle and the particle in solid is very less. That means interparticle spaces is very less in solids, whereas in liquids the interparticle spaces is more than solids. Whereas in gases, interparticle spaces means the distance between the particle and the particle is very less in gases. Next, about the interparticle forces. Interparticle forces means the force between the particle and the particle. Here, if we consider the diagram, interparticle forces in these solids is very high. That's why they are closely packed together. In this, interparticle forces are some more less than solids. That's why they are loosely packed. In these gases, interparticle forces are very less. That's why they are far away from each other. Next, about the property of diffusion. Diffusion property means intermixing of one state into the another state. This intermixing is less in solids. That's why they do not diffuse. They have negligible diffusion property, and these liquids, they show diffusion property, means they are intermixed with the another states. For example, here I took water. If I mixed with the sponge, then what happened? These liquid particles are intermixed with the sponge. That's why you can say that this show property of diffusion. Next, about the gases, they show more diffusion properties. For example, this spray, this perfume, if I spray this, then what happened? The gas coming from this is mixed with the air present in the surroundings. That's why the smell comes all over the room. That's why we can say that these gases show diffusion. They have more diffusion property. Next, about the compressibility. Compressibility means if we press to any state, then if change in volume is observed, then that is called as the compressible property. Here solids, they are not compressible. For example, if I take this duster, if I press to this, then there is no change is observed. That's why they are not compressible. These liquids, they are slightly compressible. Means if we press to the water, then a little change in volume will be observed. That's why they are called as slightly compressible. Whereas for gases, they are more compressible. They have more compressible property. This is the example for this is our gas cylinders obtained by compressing the LPG gas. That's why these gases are more compressible. This is about the states of matters. Now our question is, can these states can convert one form into another form? Yes, they can convert from one form into another form. For example, here if you consider solid by heating convert into liquid, whereas the liquids by heating convert into gases. Again by reversing, these gases by cooling it convert into liquid. This liquid by cooling it convert into solid. This is about the interconversion, and we all are know about the forms of water, that the water exists in ice, liquid and vapor state. How it is convert? Now we see. The process which convert ice to water is called the fusion process, and the process which convert from water to vapor is called as the vaporization process. Now in this class I am saying about what is latent heat. What is latent heat of fusion and what is latent heat of vaporization. Before knowing that latent heat, we have clear idea about what is heat and what is temperature. Now I will explain what is heat. Heat means it is a form of energy. In our daily life, where we see heat, if we on our gas stove, then a blue or red color flames observe. That means that flames are called, that flames are supply heat energy. And another example for heat energy is sun gives more heat energy to us. This is about the heat, and this heat can be calculated by the calorimeter instrument. Now about the temperature. Temperature means if we supply that heat, means if we keep the container on the gas stove, then what happened? That container becomes hot. That hotness and coldness of a container is called as the temperature. This temperature is measured by the thermometer instrument. Right, this is about the heat and temperature. Now, what is about the latent heat? What is the latent heat? That is, now only I said that if heat increases, means if heat supply increases, then temperature increases. But at a particular stage, if we supply the heat or if we increase the heat, then the temperature does not change. At that particular stage of increase in heat is called as the latent heat. Right. Now I am explaining about the latent heat of fusion. Here ice converts into water, that already I explained. This is the process of fusion. Now this latent heat of fusion explain the ice which is present at 0 degrees centigrade. What happened on that? That I will show an example that this is ice. If I see the temperature, then what is the temperature of ice? It is 0 degrees centigrade. After 5 minutes, what happened? This ice melts into water. If we see the temperature of water, then it is also 0 degrees centigrade after 5 minutes. Now our question was, what happened in these 5 minutes? That means, why the temperature is not increase of water? Is heat supply takes or not? Now these questions will be arise. Now I will say the answers for those questions. Yes, heat supply takes place by the sun energy. But that heat is used to break the force between the ice particles, and then it was converted into water. That's why that heat is not used to increase the temperature. Such type of heat which used to break the force between the particles by maintaining the same temperature, such type of heat is called as the latent heat of fusion. Right. Next, I am explaining about the latent heat of vaporization. This is explained is same as that of the latent heat of fusion. This latent heat of vaporization explain about the water which is present at 100 degrees centigrade. We all know that the water starts boiling at only 100 degrees centigrade. At that particular stage, the heat absorbed by water is used to break the force between the water particles. That's why the heat used is not increase temperature, and it was converted into water vapor. This water vapor is also at 100 degrees centigrade. Such type of heat used to break the force between the water particles by maintaining the same temperature is called latent heat of vaporization. This is about the states of matter and the latent heat. If you have any doubt, please comment me. Please like and subscribe my channel.